All right, welcome to section 3, part 2 of chapter 2. We are still drawing graphs of x cubed and x to the fourth equations. Today, the main difference is that we're going to talk about double roots. We're going to talk about double roots, which means that a graph crosses twice at a particular x-intercept. So the objective is to graph a polynomial function with double or more roots and to find equations of polynomials given a graph. So that is also a new topic here. We're going to find equations of polynomials given a graph. So I'll give you a picture of a graph and you should be able to come up with the equation of that graph. Okay, so we're just going to do a bunch of examples today. I think there's 5, and then we will move on to section 3. So it says, example 1, sketch a graph of the following polynomials. So we're going to do everything the exact same, except now notice that we have a power of 2 here. Okay, so that is the main difference. So what I'm going to do is I'm going to rewrite this f of x, and I'm going to draw out all my roots. Okay, so we have 2x minus 3 because it says we have a squared. Okay, so still, the rules are the same. We have to put in all of our zeros. So x plus 2 will be at negative 2. X minus 3 will be at 3, and there's 2 of them. Okay, so now we have to do our sign analysis. Let me change my color here. Let's do our sign analysis. Okay, so remember, we have zones here. We have 1 zone, 2, and now we have 3. Okay, so give me a number to the left of negative 2. So let's just try negative 4. Negative 4 take away 3 is a negative. Negative 4 take away 3 is negative. Negative 4 plus 2 is negative. 3 negatives, negative times a negative times a negative equals a negative. So in this portion right here, it's going to be a negative. Okay? So now give me a 0 between negative 2 and 3. Let's just pick the easy one. Let's pick 0. 0 take away 3. 0 take away 3. Those are both negative. 0 plus 2 is a positive. Negative times a negative is a positive. Positive times positive equals a positive. So in between the two zeros, it's a positive. And now off to the right, give me a number to the right of 3. Let's just do 4. 4 take away 3. 4 take away 3. 4 plus 2. Those are 3 positives. Positive times positives is equal to a positive. Okay, now notice, the big thing here is our 0 at 3 is a double root. Notice the signs stay the same on a double root. So here's our double root at 3, and notice it's positive on the right and positive on the left. It has to stay the same sign on both sides of a double root. Okay, so now let's draw our graph. So to the right of 3, it's positive. So we're going to draw a line going up with an arrow. Remember, in between zeros are humps, so it's positive here. So we're going to draw a positive hump. And on the far left, it is negative. Okay, so there's our graph. Now, the part that I want you to recognize, though, is this double root here. So notice what happens. It stays above the entire time, and it just touches. It doesn't actually cross the x-axis at a double root. It just goes down, touches, and goes back up in the same direction. Notice a single root, it actually crosses the x-axis. It goes from the negative to the positive. Here, everything stays positive. It doesn't actually cross. So that's very important. You should notice that double roots never actually cross the x-axis. They just touch and they go right back up in the same direction. All right, example 2. Okay, so something very similar here. We have x minus 4 squared, so there's actually 2 of them there. And then we have a 2x plus 1. Okay, so let's draw our zeros in. What is the 0 for x minus 4? Well, that's x. You add 4 to both sides, so it's at positive 4. And what about the 2x plus 1? We would subtract 1 and divide by 2. So that's at negative 1/2. So right there in between 0 and negative 1 is negative 1/2. Okay, so we have, once again, we have 1, 2, 3 zones. Okay, give me a number to the left of negative 1/2. Okay, let's do our sign analysis. To the left of negative 1/2, let's just do negative 4. So negative 4 take away 4 is negative. Negative 4 take away 4 is negative. Now negative 4 here. 2 times negative 4 is negative 8. Negative 8 plus 1 is negative. 3 negatives multiplied by each other are a negative. Give me a number between negative 1/2 and 4. Let's just do 0. 0 take away 4, 0 take away 4 are both negative. 2 times 0 is 0. 0 plus 1 is a positive. Negative times a negative is a positive. Positive times negative is a positive. Okay, so we have positive in the middle. And now give me a number to the right of 4. So let's just do 5. 5 take away 4, 5 take away 4 are both positives. 2 times 5 is 10. 10 plus 1 is 11. That is a positive. All positives times positives equals a positive. Okay, so this graph looks very similar to the last one. So to the right, let me change colors. To the right is positive. In between is still positive. And down below is a negative. So this one's very similar to the last one. Now notice once again, the double roots do not cross the x-axis. They're the same sign on both the left and the right of that double root. Okay, so that's what makes a double root so special. All right, example 3. Okay, this one is a little bit tricky because we actually have to factor this one first. It's not in factored form. So notice, what can I remove from an x cubed plus a 2x squared plus an x? I can take 1x out. Let's see what we have left now. If I take an x out of x cubed, I have an x squared. Plus 2x squared, take an x out, I have 2x. 1x, take away an x, I have 1 left over. Okay, you cannot remove that x. So, let's continue factoring now. So y equals. So x and x. What two numbers multiply to be 1 but add to 2? Hopefully you recognize that it's a 1 and a 1. Okay, so notice we have a double root again. We have 2x plus 1s. Okay, so let's draw in our zeros. At x plus 1 we have negative 1. And when it's just a single x by itself, that 0 is at 0. Okay. Now, how many zones do we have here? We have 1 on the left, 1 in the middle, and we have 1 on the right. Okay, so give me a number. So here's our sign analysis. Give me a number to the left of negative 1. So anything. So let's just try negative 4. Negative 4 in for x is a negative. Negative 4 plus 1 is negative. Negative 4 plus 1 is negative. So we have negative here. Give me a 0 between negative 1 and 0. So let's try negative 0.5. Negative 0.5, negative 0.5 plus 1, negative 0.5 plus 1 is positive. Negative times a positive is a negative. Negative times positive is a negative. So the first two are negative. Okay. Now give me a number to the right of 0. Let's try 1. 1 is a positive. 1 plus 1 and 1 plus 1 are both positives. 3 positives equals a positive. Okay, so let's see. Our double root is the negative 1 this time because there's 2x plus 1s. Notice it's negative and negative. It does not change signs, so that's what's important here. Okay, so let's draw our graph. To the right of 0 is positive, so I'm going to draw above the x-axis. Okay, in between 0 and negative 1 it is negative, so I'm going to draw a hump below. And then notice it's also negative to the left of 1, negative 1, so it goes down below. Okay, so notice once again, our double root at negative 1 here, it does not actually cross the x-axis. It just goes up and touches and goes right back down the same direction. Okay. All right, so moving on. We have a graph. Now what it wants is the equation. Okay, so this is how you set it up, y equals. Okay, now, where are our zeros at? This 0 is at negative 4. So what is the factor for negative 4? Hopefully you remember that you changed the sign. So x plus 4. Then what's our next 0? Our next 0 is at 3, so it's x minus 3. And then finally we have a 0 here. It's at 1, 2, 3, 4, 5, 6. So we have to put x minus 6. And now you could multiply all this out. It's really not necessary. Our equation is y equals x plus 4 times x minus 3 times x minus 6. So these are hopefully are fairly easy for you. Okay. And lastly, there's two more examples. Let's do this one now. So y equals, we have a 0 at negative 1, 2, 3, 4. So that would be x plus 4. And now let's notice here. Here's our other root. Does it actually cross? It doesn't actually cross the x-axis, so this is going to be a double root, so we need to put our squared. And where does it actually cross at? It's at 1, 2, so x minus 2 squared. Okay, now one last thing about this is, remember, there's two different there's two different types of x cubed graphs. There's one that looks like this one. Sorry, let me get back to the pen. Okay, there's one, and then the other one would be like this. Okay, this one has a positive a value, this one has a negative a value. So these two are the same, so we need a negative in the front because it's a negative function when it goes up and to the left. Okay, so that one's a little tricky because of that negative. And then here is your final answer. Okay, that's example 5. Now, last one, example 6. Hopefully you recognize that this is an M shape, so we know we're going to have 4 x's. Okay, so notice we have a 0 here, and we have a 0 here. Okay, what are those two zeros? This one's at -3, 1, 2, 3, so it's x plus 3. This one is at 2, so it's x minus 2. And notice neither of these cross the x-axis, so they're both a double root. Okay, now for x to the 4th graphs, we have either a w or we have an m. This one is a positive a, this one is a negative a. So we have an m here, so we have to put a negative in the front of our graph because it is a negative graph. Okay, so this one's a negative. So here is our final equation. Okay, so x plus 3 negative x plus 3 squared times x minus 2 squared. Now, the order of these do not matter. You could put the x minus 2 on the left and x plus 3 on the right. It does not matter for these particular examples. So that's it. That's chapter 2, section 3, part 2. Writing equations of graphs and writing equations from a graph. Okay, hopefully this makes some sense. I will see you tomorrow. Have a good night.